introduction. Thank you very much also to Peter to have anticipated my speech with some notes. Today I will speak about the recycling of the drain, of course, in soilless systems, to save water and fertilizers, but also to respect better the environment. I represent the company Ceres. I'm Italian, but the company is based here in Agadir. You see, we have also several activities in Italy and Holland. We are working on many different crops. Tomato, for sure, is the most important one. And we are also specialized on several soilless systems, especially cultivation in substrate, that is the dominant system here in Morocco. There are two kinds of systems in soilless, open or closed. In closed systems, you see, we reuse the water and the fertilizers continuously. Of course, the main goal is to save water and fertilizers and to avoid environmental pollution. There are some disadvantages, better to say some risks in this method. The main one is the spreading of root diseases that we must prevent. And the other one is the accumulation of some elements, especially sodium, that is the biggest issue here in Morocco. And also in Agadir, we have the problem of boron very often. To sterilize the solutions, there are several methods. The most diffused and that we have also used in our trial is the UVC system, high or low pressure UVC system. And you see there is a range of power of these lamps from 100 till 250 millijoules per square centimeter. Before the TOBY-REF, we were using middle doses. Now, after the TOBY-REF, we know that we have to use the highest dose of 250 millijoules to be sure to kill this terrible virus. Pasteurization is a system used mainly in heated greenhouse in the past in Holland, so not a perspective for Morocco. But, for example, ultrafiltration and ozone could be a solution. Ultrafiltration alone is not a solution because you see we can reach up till 0.1 micron in the pores, but TOBY-REF is 5 times smaller, so it can pass through these filters. But the combination of ultrafiltration and ozone, we think it can work well like the UV method. This is the typical structure of a fertirrigation system with the recycling of the drain. You see, we have a source of water. We have a fertirrigation unit and the tanks with the fertilizers and the acids to correct the pH. We have the crop. After the crop, we collect the drain in a contaminated drain tank. From there, the water, the drain, is going to the disinfection unit. It is accumulated again in another tank that we call the clean tank. And after that, we need a device called Drainamix that mixes the original water, the irrigation water, with the drain water to obtain a fixed value of EC in the entrance of the fertirigation unit, and from there we restart to give the nutrition to the plants. We did the trial together with APFEL and our partner Spagnol in the demonstration of the APFEL here in Agadir, 5,000 square meters, the size of the trial. Here you see the equipment, the automatic dosing unit with the stock tanks behind. And on the left, you see the sterilization with the UV lamps, and behind the 2 tanks with the clean and dirty drain. The basic element of the disinfection is this UVC lamp that also in our system we calibrate at 250 millijoules because the risk of TOBY-REF, is very high here. Here you see how the lamp works. Around 1 lamp is enough for 1 hectare to manage the drain of 1 hectare, just to give you some parameters. And very important to have also a good filtration system and also to inject acid and peroxide to keep clean the lamp to avoid the so-called shadowing effect of organic matter in the nutrient solution that can protect the potential pathogens from the effect of the UV rays. We have chosen for the collection of the rain these gutters, plastic gutters. You see they are laying down on the soil beds. We have taken this decision to have the maximum thermal buffering effect by the soil. It means cooler roots in the summer, warmer roots in the winter, and especially very important to have this device called spacer inside the gutters to avoid the possibility the roots can be in contact with the drain, because if it happens, there is the risk that you transmit the diseases before they reach the disinfection. So very important to have this space inside the gutters. This is the result that we got in this trial. The graphs are coming from 3 master theses that we did together with the local complex horticole. 3 master theses that analyze all the parameters of this trial. Here you see, for example, in April we had a presence of fusarium in the drain, orange column, and in gray you see the result after the disinfection. It was 100% eliminated. Coleototricum, not so dangerous like fusarium, but could be also a problem. You see again a presence from April till June, and we have eliminated almost 100% also this disease with the UV treatment. Presence of pythium end of the crop, again, good result, 90%, but the remaining 10% was not effective on reducing the activity of the roots. We had also a presence only once of Clavibacter, and we have seen that the system has eliminated 100% of the Clavibacter. And here are the results about the EC and in the supply, it means in the drip and in the drain. You see the modification that we applied to the drip EC from February till June. Because most of the greenhouse was cultivated with large tomatoes, we decided also to reduce the target in the drain during the experiments, and this choice, I think it was successful. What was the modification of the nutrient solution? Here you see on the left the solution that we were using in this greenhouse the year before in an open system. And on the right, you see the concentration of the macro elements in millimoles per liter and microelements in micromoles per liter. In general, you see we use half of the fertilizers, half the concentration in the solution calculated for closed systems. And you see also the total EC was quite lower for the closed system. The final result in terms of water and fertilizer saving, you see, was very interesting. We have reused 81% of the collected rain, and around 45% of the irrigation water was coming from the drain. It means we could say that this system has guaranteed water saving of 45%. The shortage of water, you know, is problem number 1 for the growth of the agriculture sector in Morocco, especially the greenhouse sector. So we have seen that with this water saving of 45%, and we have reused also 75% of the fertilizers, these 2 savings, water and fertilizers, could say to us that in 3 years you pay back the investment in recycling. So, very good results. We are very proud of it. We arrange very often together with APFL also so-called technological transfer. We invite frequently a group of growers to visit this station where we can see several things. We have now also a new website and also a LinkedIn account. If you want to visit, you can be updated continuously about our activities. Because I repeat, we don't do only consultancy, but we do also researchers that are in favor of the agricultural sector of Morocco. I take the opportunity, because I see I have a lot of time, to show you another experiment that we did in combination with this trial of recycling. together with APFL and our partner Exafar, we applied these 3D hyperspectral cameras to do the yield forecasting. That it is another important issue for the local growers, especially the big groups that export directly to supermarkets in North Europe. They have very often the problem to predict what will be the harvest, the production in the coming 2-3 weeks. So we have done this trial, and the result was really very interesting. We have chosen a round tomato caliber 2 as a reference crop. You see, in the beginning, we started the trial in January, February. We had to calibrate the system, but in the other graphs, you see the difference in between the green column, harvest, it means real harvest, and the purple column, it means the forecast up on 3 weeks. It was very, very high, the accuracy around 90%. Not in this trial, in another trial, in mini plant tomato, the accuracy was more or less the same, more than 90% up on 3 weeks. Very often, the forecast on 3 weeks is more accurate than the forecast for the next week. But in any case, the value is very high. Our partners are somewhere in the room. If somebody is interested to know more about this trial, we are available, of course, to share with you also the results. In the near future, we will use the same cameras also for the crop registration of the crop. It means to measure the growth of the plant and several growing parameters. And we will use the camera also for the detection of diseases in the crop. We have also a research station of 4.5 hectares here in Agadir. You are all invited to visit us and to collaborate with our programs. Till now, we have always invested alone, together, sometimes with APFL, sometimes with some partners, but we would like to find more cooperation by the local growers to work together to upgrade our knowledge about these important subjects. Next season, we will try about recycling 3 new gutter systems, and also we'll test the ultrafiltration and ozone system together to compare it with the UV disinfection. I thank you for your attention. I have seen that I respect the time. If there are questions,